All right, so we are going to continue our talk of discrete random variables. So just a friendly reminder, a random variable takes on a numerical outcome, and a discrete random variable has a countable number of possible outcomes. So what we're going to be focused on today is the mean and the standard deviation of these random variables. So first, let's think about the mean here. So another phrase you'll see associated with the mean of a random variable is the expected value. Okay, so we're going to reference again this this example with the kids that played with a certain number of toys when they were presented with 5. Okay, so you could think about that as, if I put a kid in this room, how many toys would I expect them to play with? Okay, so this is different than a regular old mean or average because it takes into account the fact that not all outcomes are equally likely. So I am not just finding the average again in this toy example. I'm not doing 0 plus 1 plus 2 plus 3 plus 4 plus 5 and dividing that by 6. That would just be the average. This is taking into account that, kids are more likely to play with, 2 or 3 toys as opposed to 0. Okay, so we sometimes heard this or hear this called a weighted average. So it takes into account that some outcomes are much more likely than others. This is also the long run average outcome. So if you were to, look at many, many random selections out of a probability distribution, what would the average look like? Okay, the notation we use is mu sub x. Okay, if we're going to get to the point where we're looking at more than one random variable at a time, and we would call that mu sub whatever variable you're dealing with. So mu sub x, mu sub y, mu sub whatever. Okay, so here is the equation. So we have mu sub x. You'll sometimes see it written as this. E stands for that expected value again. So the expected value of x, the mean of x, same thing. So what we do is we take our outcomes and we multiply it by the probability associated with that outcome. Okay, we do that for every single outcome and probability combination, and then we find the sum. We add them all together. Okay, so we're going to do an example here where we look at, this is just that toy example again. Okay, so we're going to look at the outcome, multiply that by the probability. Okay, so if I'm finding the mean, right, mu sub x is equal to, I'm going to take the value, so here the value is 0, and multiply it by the probability associated with 0. Plus, my next value is 1, multiplied by the probability of the probability associated with the value of 1, sorry. Okay, same thing. So now I have an outcome of 2 with a probability of 0.3. Now I have an outcome of 3 with a probability of 0.23, plus an outcome of 4 with a probability of 0.17, and last an outcome of 5 with a probability of 0.11. So when I multiplying the outcomes by these probabilities, you can see that like this is going to weight the heaviest because it's being multiplied by 0.3, where 5 is only being multiplied by 0.11. Okay, so typing that in the calculator, we see that we end up with 2.68. Sorry, I just want an X there. Okay, so now we were also asked to interpret this. So what does that mean? So if it's the expected value and it's in the long run, so I want to think about the long run here would be many children. So if many kids were to participate in this experiment, they would play with 2.68 toys on average. So that's exactly what we are going to say. Many children were to participate in this experiment, they would play with 2.68 toys on average. Okay, so that's mean and expected value. You guys want to get in the mindset where you're using the two of those things interchangeably, mean and expected value. Now we're going to look at variance and standard deviation. So we've talked about standard deviation before, and we've talked about variance, but it was pretty briefly. We calculate variance, and then we move from there to standard deviation. So a lot of times we're more interested in standard deviation, but you calculate the variance first. Okay, so variance is just standard deviation squared. So I'm going to use sigma squared sub x. Okay, if I were looking at a variable called y, I would put y here, whatever it is. Okay, so the way we calculate the variance, this one has a lot more to it. So I take my first outcome, so x sub 1. I subtract it from the mean. Okay, so I want to measure how far it is from the mean. That value gets squared. And then I'm going to multiply it by the probability associated with that. So I'm going to say p sub 1. Okay, plus I do the same thing for the second outcome. So my outcome minus the mean squared times the probability associated with the outcome. Okay, I do that for every single outcome that we have. All right, so the idea is I'm measuring how far each value is from the mean. The reason we're squaring it is because sometimes when I measure this difference, it's going to be negative. Sometimes positive, sometimes negative. I don't really care if it's positive or negative. I don't care if it's less than or greater than the mean. I just want to know how far it is. Okay, so that's why we do the squaring, and that's why this is variance and not standard deviation. So to get to standard deviation, all we have to do is take the square root of that variance we just found. So the standard deviation of x is equal to the square root of the variance, which is what you would get with this big giant formula here. So that's why I said we usually calculate variance and then from there go to standard deviation. Okay, so we're again going to use this toy example. So I'm just going to steal it and bring it over here so we can see the values. Okay, so I'm going to need to know the individual observations. So 0, 1, 2, 3, 4, 5. I've got the probabilities, and I need to remember that mu sub x was 2.68. Okay, so let's set this up here. So this is going to be a big one. So I'm doing variance first, and then we'll move to standard deviation. So I'm going to take my observation minus the mean, okay, which we just found to be 2.68. That gets squared and multiplied by the probability associated with 0. Okay, so it was 0, so I'm using 0.03. Okay, we do it again. So I take my observation minus the mean, square it, multiply it by the probability associated with that observation. All right, keep going. So my observation minus the mean, square it, and multiply by the probability. All right. We'll keep moving here. So 3 is my next observation, minus the mean, squared, times the probability. Next observation, minus the mean, squared, times the probability. And then the last one. So my observation, minus the mean, squared, times the probability. Okay. So then we would be typing all of that in our calculator. So I'll give you guys go ahead and pause and do that. All right, so overall you should have ended up with 1.1 or 1.31. Sorry, not 1.31. For the variance, we get 1.7161. Okay, so we actually wanted the standard deviation of x. So to do that, we take the square root of what we just found. And that's 1.31. Okay, so here's the part where you all hate me now. So there's actually a much simpler way to do this than writing all of this out. So I have you do this because there is a caveat. You do have to show part of this work on the AP test. But for the most part, the calculator will do the work for you. Okay, so what we do is, so we're going to talk about the steps and then I'll show you how to do it. So you're going to put the x values or the different observations in L1, the probabilities associated with those observations in L2, and then we're going to do one var stats with L2 as the frequency. So the deal is, though, you must write out the beginning of the computations on the AP test. So we'll do that again for that toy one. So let me, once again, steal this so we can see it. Okay. So we are going to go to our graphing calculators here. And we're going to enter in the list. So you're going to go to Stat and enter. Go ahead and clear out whatever you may have in there. Okay, so in L1, I'm going to put these values, 0, 1, 2, 3, 4, 5. L2, then I'm going to put in those probabilities. Okay, so you can see mine there as well. So now I'm just going to quit back to my regular screen, and we're going to go to Stat, over to Calc, and one var stats. So we've done plenty of one var stats before. The difference is we've always left this spot blank. So now what we're going to do is we're going to put L2 here. So this is going to say us like, or this is going to tell the calculator for that observation of 0, I want that to occur 3% of the time. For the observation of 1, I want it to occur 0.1 or 16% of the time, and so on. So let's calculate. So we get a whole bunch of stuff here. So we can see our mean is the first thing, and that's what we found earlier. 2.6, ours was 2.68. We must have rounded somewhere in there. And then our standard deviation is the sigma sub x, so 1.3. You know, I wonder if I entered something in wrong. I did. Right here, this should be 0.23. So you guys are probably screaming at your computer that, Miss McQueen, you missed it. Okay, so let's try that again. There we go. 2.68, 1.31. Okay, so now we're in business here. Okay, so I'm going to show you if you were to receive a problem like this on the AP test, what you're going to write. Okay, so you're not just going to write mu sub x equals and then the value. You are going to do mu sub x equals, and then you're going to begin the formula. So 0 times 0.03 plus dot, 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 plus, and then you're going to show the last one. Okay, then you can say equals whatever the calculator found. So here, 2.68. Okay, so you're showing you know where it starts, where it stops, and that you're doing everything in the middle as well. Here, when you're doing standard deviation, same idea. So I'm going to show the beginning. So my observation minus the mean squared times the probability plus dot, 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 plus, and now I'm going to do the same thing for my final value. Oops. So 5 minus 2.68 squared times the probability. And something to remember, This is not the formula for standard deviation. This is the formula for variance. So if I want to do that, I need a whole big giant square root over the whole thing. Okay, then I can show that that equals 1.31 because that's what we saw from the calculator. Okay, so from now on, you are able to do it in the calculator. However, the caveat, you must show part of setting this up. Okay, so last thing we're going to do here, understanding check. So it's just finding the mean and the standard deviation and interpreting. So go ahead, try that, come back and see how you did. All right, so I'm guessing most of you did the 1var stats. I know I definitely would have, but make sure you are showing the beginning of those formulas. So overall, for number 1, the mean ends up being 1.1. You should have had on your paper mu sub x equals 0 times 0.3 plus ... 3 times 0.1, then equals 1.1. So if we interpret this, we would say if many Fridays were randomly selected, the average number of cars sold in the first hour would be 1.1. Okay, number 2 then, same idea, but standard deviation. So we can see it. Okay, the value you should get is 0.943. We say the number of cars sold on a randomly selected Friday will typically vary from the mean by about 0.943 cars. Remember, standard deviation measures distance from the mean or average or typical distance from the mean. All right, so that's the end of discrete random variables here. Next time we will talk about continuous random variables.